Hello and welcome to today's daily Leetcode challenge. Today we have another easy question, 661, image smoother. So let's get to the description, then go over the solution process and the thinking process, and then the implementation. So an image smoother is a filter of size 3 by 3 that can be applied to each of the cells on an image by rounding down the average of the cells in the 8 surrounding cells. Rounding down the average of the cells of the cell and the 8 surrounding cells. The average of the 9 cells is the blue smoother. Okay, so each cell in the input image can be smoothed by taking the average of the cell plus the 8 surrounding cells. Okay, that so far makes sense. If one or more of the surrounding cells is not present, such that basically if we're on a border, we do not consider it in the average. So the average is the sum of the cell values divided by the number of cells. If we're on a border somewhere, and there's many instances of borders, there's the border where there's only 4 cells present. There's also a border where there's 6 cells present. If it's not on the corner, then the sum over of all the cells divided by the number of cells, and the number of cells here is going to be 4. Okay, if we do not consider it in the average, given an n by m integer matrix, IMG, represent the grayscale of an image, return the image after applying the smoother on each of the cells. Okay, so description's pretty easy, but the let me just put it in my own words. I have an image and I want to smooth it. The way that I'm smoothing it is applying this consistent smoothing technique where you take the cell and the cells around it and take the average. I mean, really, this sounds pretty simple. The implementation of it is also similar to other matrix traversal questions. Let's look at the constraints. We have the m equaling the number of rows and the number of columns. The image itself is not that large, only 200 cells max, or the length and the height of max 200. And the values are between 0 and 255, which actually is the general representation of any one single hue or color in a cell. Okay, so the implementation. Well, let's traverse the array. Apologies. Let's traverse the input matrix, and as an initial step, count the number of cells that are going to be around that cell. So this is going to be conditionally. This is going to be conditional. Sometimes it's going to be 9. At most, it's going to be 9. Sometimes it's going to be 4. Sometimes it's going to be 6. Let me get some of these values in here. Let's say m is equal to len of img, and n equal to len of img at the first row. So m is the number of rows, n is the number of columns. Let's say for I in range n, for j in range m. Actually, let me do this instead. N. Let me. Okay, so quickly, what am I doing here? Here, I'm iterating over all the possible positions of the matrix. But what I need to do, in addition to looking at each cell in the matrix, I need to figure out what is the possible surrounding cells. And the way that I'm going to do that is I'm going to have 2 more loops, nested for loops. I'm going to have I, Y, in range. And I'm going to quickly talk about this. I'm going to talk about what I'm doing here after. I need a max of 0 and I minus 1. And this is going to be going to minimum of len of m minus 1 and I plus 1 plus plus 2, and this is going to be like this for j x in range. I'll explain exactly what I'm doing here in just a second. J minus 1 min of n and j plus 2. Let's have a cell. It's here equaling to this. Oops. Cells plus equals 1. Print cells. Okay, now what did I do here? Well, here's my idea. If I'm looking at cell 1, let's say that I'm looking at this 7 right here. One way of looking at all of the possible surrounding cells is spelling them out, saying one of the cells that I'm going to be visiting is I minus 1, j minus 1, which would be pointing at this. The other cell is going to be I minus 1, j, I minus 1, j plus 1, which would be pointing at 3, and so on, right? I have then I minus I, comma, j minus 1, I, j plus 1, and then so on. You get the point, right? I can spell out those 9 different positions. But what another person might say is, hey, why can't I just traverse this like I'm actually doing with the original input matrix? Why can't I just have 2 for loops with a predefined range, which goes something like from I minus 1 to I plus 1, and then from j minus 1 to j plus 1, right? Defining the left bound, the right bound, the top, and the bottom. And that's actually what I'm doing here. I'm defining for IY, that's my vertical. For my vertical, which here it's defining the number of rows, here's iterating over the number of rows, and here it's defining the top bound and the bottom bound. Now, why do I have these max and mins here? Well, because when I'm standing on the edge, I could conditionally in here say something like if I y is less than 0, meaning that we've stepped outside of the bounds, I can say continue, right? But an easier way to do this is just to have this logic within the range itself. And what this is saying is if in the case that I minus 1 happens to be smaller than 0, well, I'm going to be cutting that off with having this max choose between a number that is 0 or anything greater. Well, 0 and anything else, right? So if the number is less than 0, it's obviously going to pick 0. Same goes with the min I plus 2. And so what I should be getting here right now is 4, 6, 4, 6, 9, 6, 4. So what this is actually on this input is the 4 cells, then the 6, then the 4, then the 6, then the 9, then the 6, then the 4, then the 6, then the 4. Perfect. That's all I needed. Now I also need a sum, right? And this sum is literally just going to be I am j I y j x, And I also need a result. Let's have the result be here. This is going to be n for in range m. And res, I'm going to be setting here as an I, and the j equaling s divided by cells. Return res. Here I define the output matrix, which is identical to, or in dimensions is identical to imj, and here I'm setting the smoothing function, right? S was just the sum of all the values surrounding the cell that I'm currently looking at. Cells is the number of cells, and S divided by cells is going to be our smoothing function. And so then I return, and we should be set. Let's see how we did. Well, at least that's correct, and we're not doing too bad. 60%. I wonder if they've implemented something, if they're using some external function or libraries. They're using NumPy. We're not going to be doing that, and the rest, I presume, either defined. They're probably doing the same thing. So I guess we're. This is a perfectly sound solution, and I see that there's a spike of solutions of this sort in here. So yeah, let's end it here. Please use this if you want. Like and subscribe. Leave any questions in the comments below, and I'll see you tomorrow. Thank you. Bye.